Hi, my name is Mark Walker. In this unit, we'll be discussing IBM WebSphere Application Server Standalone Edition. This architecture covers the basic functionality and components that are used across really all editions of WebSphere. So even though it really will be referring a lot to IBM WebSphere Express and IBM WebSphere Application Server Base Edition, all of the same information does in fact, or indeed, apply to IBM WebSphere Application Server Network Deployment Edition. The unit objectives that we're going to try and cover here will in fact just to describe the basic e-business architecture, how a normal application is put together, the different components that it actually uses, and how all the different pieces work together. As well, we'll take a look at the different packages and their roles and their responsibilities. And one of the neat things we'll cover is we'll do a walkthrough of how a request starting at the browser flows all the way through to the back end. And we'll discover some of the implications of how you would set it up and configure it, specifically things like the web server plugin, as well as the use of data providers using JDBC. So to start with, there are three topics that we're actually going to go through. The first one is the architecture runtime. Those are the running components of the basic part of WebSphere Application Server. And then we'll talk about the different components for architecture administration, how you make this stuff all work, how you manage it, and how you use it. And finally, we'll talk about the role of profiles, literally a collection of files that group together to provide a specific set of functionality that you want a WebSphere Application Server instance to have. So let's start with the architecture runtime. If you take a look at the diagram that you see in front of you, you'll see a full-blown Network Deployment Edition as a top level. And in that, you'll see components like the clustering, the node agent, the deployment manager, intelligent management features, as well as the web service gateway. These are product components that are specific only to the WebSphere Application Server ND, and of course, the WebSphere Application Server for ZOS. But in that nice big bright blue box that you see there are the base features. These are available to all application server instances, so all versions of WebSphere that you're actually going to be running. They provide the basic sets of functionality that you're going to use, whether it's Express or Base or Network Deployment Edition. So if you look, you'll see that it provides some specific common features. So for example, the web services components, the messaging components for like JMS and working with MQ, your actual Java developer kit, the web container components, so that means a JEE web container, which does all the web container services, including your servlets, your JSP pages, your servlet filters. The EJB or enterprise container, which is where you would deploy your enterprise Java Bean components containing your application business logic, as well as some additional features to run all this. For example, the web-based administration or the ISC console, or the WSAdmin command line tools that you can use to run and administer a WebSphere Application Server instance. They're shared across all of them, as well as PMEs. Let's get down to IBM WebSphere Application Server Basics. So what is a WebSphere Application Server? It is literally a JEE compliant application server instance that runs on a Java development kit. So a WebSphere Application Server provides specific key features. For example, a web container, an enterprise container, JNDI lookup, and a lot of other services that are required to be a compliant JEE container. So if we look at it from the big perspective, what we see is we have an application platform, WebSphere Application Server, running on top of an operating system or some other type of platform like VMware, running a Linux or a VMware container. And that platform then itself hosts applications, which it offers up the services that it provides to acting as a bridge between the underlying operating system and the actual applications running within the JEE container. So if we do the walkthrough, and this is kind of slick, so as you walk through this, you basically start with the browser as an example. And it could be a thick client application. It could be another application running on another server altogether that's doing a web service call. But assume that we have a WebSphere Application Server infrastructure that we want to have service a request. So normally, in a typical run-through of a web application, you start with a browser. What the browser does is someone will go in, fill out a form, and they'll click OK, and there'll be what we call either an HTTP post, an HTTP put, an HTTP get, some type of HTTP request that will be sent over to the WebSphere Application Server. But typically, it doesn't go directly to an application server. It's going to go to an HTTP server. And there's a reason for that, because typically, most of your content, or a lot of your content, is going to be static. And by static, we mean it's content that doesn't change. It's not dynamically generated. It's, for example, pictures of your latest products or your front page telling people about your company or your organization. So what happens is the person hits the button, the post button in the browser, and it's going to send the request over to the HTTP server. And we can actually see that here. The HTTP server is going to look at that request, and then it's going to look in its own configuration, and it's going to find out via looking in the configuration if it's supposed to serve it or if it's supposed to pass it on. And what WebSphere provides is something called the Web Server plugin. And the Web Server plugin is literally an add-in to your HTTP server. And there's a lot of HTTP servers that are supported, but for example, IBM HTTP server, which is a version of the Apache server, or Apache or some other server. For example, IIS. So what happens is the HTTP server then looks to make sure it's supposed to serve the content itself or whether or not it's going to send it back through the plugin. In this case, let's assume it's something that's going to actually be calling a Java server page or a servlet. And this is all determined from the URI. That's the part of your URL that happens after the host name and your port. So if we have a look at this, what we see is that the plugin is determined to send it to a server. Well, WebSphere itself has an embedded server in it. So that means you could actually bypass an HTTP server, and that works great for software development, not so good in a real enterprise application. In fact, in most enterprise environments, the HTTP server is going to be sitting outside of your firewall, and the WebSphere application server instance is going to be sitting inside of your firewall. So you're going to make the request to the HTTP server, it's going to move over to the embedded server, and the embedded server is going to see which modules it's supposed to serve up, or literally what it's going to call within WebSphere. So it then makes a call over to either the servlet or the JSP, i.e. the web container that it's actually requesting the resource from, which will then process that request. So now we have a web server servlet or a web server JSP page, for example, and it's going through its logic. And as it gets to its logic, at some time, it's probably going to have to call a backend. So in lighter applications, all of your code will be in your web container. But in real enterprise applications where you have distributed enterprise services, you're going to embed that not application logic, but that business logic will normally be embedded within your enterprise Java beans. So you'll have session beans that manage application state, manage what you're doing, stateless session beans that do services or do service calls. You'll also have entity beans that represent specific things like an account or a person or a product. In effect, your servlet's going to have to call those back-end services. So what we'll see is if we look at the next thing, we can actually see that our application server servlet would then call the back-end. And it's changing now. So instead of being an HTTP request, which has been from the browser to the HTTP server, from the HTTP server to the embedded server, from the embedded server to the web container, it's now going to have to talk to the EJB container using a more complete type of protocol, one that's designed to basically include more information. In this case, it's something called RMI over IIOP, or Remote Method Invocation. And it's a Java way of doing CORBA, which is the Common Object Request Broker Architecture. So in essence, what it is a special way to be able to call other servers on other machines. In this case, we're actually showing it in the same WebSphere application server. And the truth is, you can bypass this. There's a way to actually call EJBs locally that don't require all the protocol that's involved in an IIOP request. But in a real world, your backend is probably not going to be running on the same application server that your web application is going to run on. Your backend, your EJB container, will actually be running as an enterprise container somewhere even further back in your infrastructure, and it will represent the way that you access your data at the back end. So what we end up having in this case is we use IIOP so that when we do need to scale it, even though right now we're showing it as local, in effect, in a distributed environment, it'll still work just fine. So we have our call from our servlet now, back to our EJB, which is now going to do some processing. And this is the stuff you'd normally expect to be business processing. So for example, updating an account. So its job, the EJB container's job, is going to be called the data layer, which is the furthest back part of this whole entire model. So if we look at this, we actually see the enterprise Java bean now calling application data, which could be a DB2 database, it could be a legacy system, and there are all different ways it can call. In this particular example, they're describing it as JDBC, but it just as easily could be an IMS call or an MQ call or any number of other ways to call the legacy systems in the back end. Although for the most part, it will usually be SQL of some sort using a JDBC call. In addition to that, there's a number of other components that are built into the JEE container. And that's what we're talking about here. It's not just WebSphere, it's the requirement to be a properly formed, fully implemented JEE container. So for example, we need the ability to do dynamic caching. Dynamic caching is essentially caching that's done for data that does potentially change. For example, your Java server pages, which will generally always serve up the same content, but could potentially serve up different content. So you want an ability to have it not have to redo a page if the data hasn't actually changed. As well, we need the ability to make sure the information is replicated. What happens if you have server A and server B and your workload managed across them? We would need some way to make sure that the session state for a specific user is actually replicated between those two instances. We have the Java management extensions. That's your JMX you see listed there. So we need a way to be able to issue commands from even our applications, as well as any other consoles or extensions we want, to a WebSphere application server. And we use JMX with MBeans in order to be able to do that. As well, we want the security infrastructure that a JEE container is supposed to provide, so we can ensure that we are only accessing our data and the services that wrap our business logic in a way that we are allowing the users that we're expecting to do it in the roles that they're supposed to have in order to be able to do it. As well as the naming server, that's our JNDI lookup server. So how do we find our business service when we want to do it? And that's where you have a JNDI lookup for. So what you see is that the application server core, the runtime architecture, provides the basic flow from front to back, as well as a number of other services so you can lock it down so that you can make sure it'll work across multiple machines. And that's built into the application server infrastructure from the beginning, directly into the container. Now, in addition to a standard Webflow, there's other ways that information can be requested from a WebSphere application server instance. So in this example, what we actually see is the browser bypassing the HTTP server to go to the embedded HTTP server. And as you can see, really works the same way, everything does the same thing. But we can also have external Java clients. These are thick clients or other applications, and they may also need to be able to access our WebSphere application server. So in this particular case, we have a Java application, a thick client running somewhere that we want to access the actual business logic enveloped in or encapsulated in our EJB container, in an EJB. So in order for it to access it, it also will use RMI over IIOP to do a connection from the Java application directly to the EJB container. And all it needs for that, obviously, is the EJB client jar. And if you want to add even more complexity, you'll know that most WebSphere application servers running in the center of any particular infrastructure also have to provide their services via other mechanisms to other applications, especially other application platforms. So say you actually have some applications written using the Microsoft tool suite, or you have other servers running in legacy and you want to be able to access your new services. Well, to do that, we would use the web services client. So literally an application that actually has a web service client jar for a specific web service installed, and it will make that request via HTTP usually, and it will have to go through the same stack through, in this case, the web services engine, which will map the web service and the protocol it's using to the specific implementation of a service. We would call this like an early version of an enterprise service bus. Finally, we have an example of a web service client or a JMS client accessing or interacting with a WebSphere application server using the messaging engine. So this would be an example of a client using JMS, for example, to access our application server. And WebSphere is kind of slick this way. It can actually be a JMS provider, or it can wrap a JMS provider. So you could, under the hood, if you have a very large complex infrastructure, plug in a WebSphere MQ and actually make it the JMS provider for a WebSphere application server, and then the WebSphere application server would present that to the consumers, or WebSphere application server itself can be a JMS provider and use or not use MQ or some other messaging engine under the hood. So another feature that has to be provided as part of any enterprise infrastructure are JDBC providers. And when we talk about JDBC providers, it's really a bad way to describe it is that JDBC, Java Database Connectivity Provider, because it's really essentially much more than that. Typically, when you're accessing your backend, and I don't know if you've been paying attention to licensing to databases is relatively expensive. So when you're going to your backend, what if you have 100 application server instances, and each of them could potentially have hundreds of clients connect, and you have a database at the back end? Are you going to spend money on 1,000 licenses to go to your Oracle database, not to mention the overhead? Add to that fact add to that fact, the most expensive part of dealing with a back-end system, we're talking about non-legacy here, is the actual connections to the database. We're not talking about going to the database and getting data. We're talking about just setting up the initial connection, which requires setting up cursors and all that other stuff to the database. So one of the JE requirements is that we create something called data pools. And a data pool, using a data source, allows us to have fewer connections for more people to go to the backend database. So if I have one person connecting to my application in WebSphere, I would need one connection to a database. But if I have 10 people connecting to my database, or 10 people connecting to my WebSphere, chances are they're not all going to be doing database stuff at the same time. In that case, I could probably get away with 5 database connections. So what connection pooling does is it allows us to create 5 connections in a pool, but then 10 users or 20 users or whatever can now access those connections, and I don't need a connection per user. To do that, the data source requires that we support something called database drivers. And there's a number of different types of database drivers. What you see listed here, type 2, type 3, type 4, are the standards. There's actually originally a type 1, that's the JDBC ODBC bridge. We don't typically talk about it, and most people don't implement it unless for some reason you need to go to, say, a SQL Server database at the back end. What most people use are the type 2, type 3, and type 4 drivers. But even those drivers, it's important to understand how they play or the role they play. So the type 2 driver is what we call a thick driver. And it's not discussed here, so I'm going to talk about it over here on this board, and we're going to have a little look at it. But we want to talk about how a database is connected to by an application and where that information is, because it helps you understand the differences between a type 2, a type 3, and a type 4 driver. So just give me a second here to get established. I'm going to go in a little bit more detail about JDBC drivers because they're one of the least understood aspects of any JE container and the services it provides. And they also can have the most impact on how well your enterprise application will actually work. So what you'll see listed in the diagram here is that they're talking about 3 types of drivers. And I think I mentioned already the JDBC ODBC bridge, which isn't listed here. But more importantly, there's type 2, type 3, and type 4 drivers. And there's some critical things that have to be understood in order to properly implement or choose which drivers to implement based on your infrastructure. So we're going to start by just looking at the type 2 and type 3. They're basically the drivers that are written in the language or tools of the software, and they require that you actually install the Oracle or DB2 database own software client for that particular database. But there's a critical difference between type 2 and type 3, and they can dramatically impact performance. So if you actually think about a normal environment, you're going to have your WAS application server sitting at one part, and you're going to have a database sitting at the other part. So we'll make it a DB2 database. And obviously, we're going to want to connect to our database so we can use a driver. And the decision really needs to be made on which driver to use based on your topology. And normally people wouldn't think of that. But when you look at how any database is actually used by any connectivity functionality that you're using to connect to it, it uses something called a cursor set or a key set. So when you do a select, for example, or an update or anything that you're going to do that involves more than one row with the database, it's creating a cursor. Okay, and that cursor literally has the primary key to what you're trying to access to and a pointer to it. So then as you roll through and iterate through your rows to do whatever work you're doing with it, it's going to move up and down through that cursor with the data. So here's the trick. If your WebSphere application server instance is actually running on the same machine that your DB2 is running on, you don't want to have to do any extra work for it. You want to maximize efficiency. So you maximize efficiency by using something called a thick client, or in this case, a type 2 DB2 driver. And what that thick client does is keep the cursor set literally with the client software. So when you go to do your select, it pulls down all of the rows that you need to actually do the work. And that means it's very efficient. You don't have to wait for rows to be returned. Your code can then iterate through all of your rows, do all the things it needs to do very quickly and very efficiently. The problem is if there's a network between you and DB2, i.e. the database server isn't on the same machine as your WebSphere application server, what ends up happening is you're now pulling down all of the rows for your key set, and you may only need one row. You're killing the bandwidth of your network, you're slowing everything down, and you're making 2 machines do a lot of processing that they may never need to do at all. So in that case, when they're on separate machines, we use a type 3 driver, which manages the cursor set on the same machine as the database server. Now, as you go from row to row, it only has to return the row it needs. If you have large data sets you need to work with, that can be slow. But if you think about a network as being shared by a lot of other devices, not just the one you're working with, not just the application server you're working with, but many other application servers, many other client applications, all that need to connect to the database or transfer data or move things around in your infrastructure like all organizations do, it's critical that you know the difference between the type 2 and type 3 driver. Now, here's the tricky part. There's a type 4 driver, and it's a native, all written in Java driver. And its problem is it could actually be a type 2 or type 3, type 4 driver. I know it kind of sounds funny. What we're really saying is which side is that cursor set on. So it's important that you know, and usually it's the same as a type 3 driver, but it's important to understand what you're implementing and which drivers you're using in terms of that functionality. Now, the other thing to need to know is how that driver will implement transactions. And one of the confusions are people see XA and they assume they need XA to actually be part of a transaction with their database driver. You don't. What that JDBC connection always has is the ability to take advantage of the transactionality that's provided built into the database itself. So if I connect using an Oracle database driver in my code, I can actually issue a begin trans, or DB2 driver, by the way. I can start a transaction with a begin trans. I can actually do embedded transactions if I want. And when I'm done, I can either commit or roll back my transaction. But in the situation where I need my relational database connection to participate in a transaction with other databases. So I have a DB2 one that has my account information, and I have an Oracle one that's got my SAP information for my customers. And I have another legacy system at the back end that I connect using a web service in the context of a transaction. Those transactions aren't embedded to the database. Those transactions are what we would call extended or XA transactions. And those transactions, in effect, need special functionality. So a type 4 XA driver supports literally distributed transactions, or uses the OTC Open Transaction, OTA Open Transaction API, using the OTS Open Transaction Services specification. And if you use those services, you must use an XA driver. And if you don't, you can get better performance using a standard driver. So anyway, it's really important when you're working with JDBC that you understand what the drivers are, how they're implemented, and how they can impact your applications based on how you use your applications and the topology of how you've implemented your infrastructure.